Picture this. You've just finished developing that massive project for your client. You're sipping coffee, feeling like a coding genius, when suddenly, boom, your computer goes blue screen. Or imagine you're working with a team. You have no idea how to send them your code. What do? Email a zip file? Too messy. Copy-paste chunks of code? Yikes. There's gotta be a better way, right? Enter Git and GitHub, your new best friends for collaborating like a pro. Let's dive into how they can save you from these coding nightmares. Let's first understand what is GitHub. GitHub is your code's digital home, a place where you can store, share, and collaborate on projects with people from anywhere in the world. Git, on the other hand, is the version control system that powers everything behind the scenes. Think of it as the tracking tool that knows every change you make to your project. It's like having an infinite number of undo buttons, so if something breaks, you can always roll back to a working version. It lives on your computer, keeping track of every change you make to your project, whether you're editing a single line of code or adding a whole new feature. You can think of Git as your project's time machine. It lets you go back to any previous version of your code, so if you mess something up, you can always undo it. Simple, right? To understand Git more in depth, let's explore how to use it. First things first, you'll need to download Git onto your computer. Without it, Git won't know what's going on. So head over to Git's website, download it, and install it like you would with any app. After downloading Git, go ahead and launch Git Bash. It's like your control center for Git. Git Bash is just a fancy name for the terminal where you'll be giving Git all its commands. Think of it like your direct line to Git, where you tell it what to do, like tracking files or saving changes. For example, let's say you're working on a website with a couple of files, an HTML file and a CSS file, and you want Git to start paying attention to any changes you make. That's where Git init comes in. So what does Git init do? When you type Git init in your project folder using Git Bash, you're basically inviting Git to start tracking everything. It's like telling Git, hey, start watching this project. Think of it as setting up your project's save system, so Git can remember every change from now on. After you run Git init, Git creates a hidden folder called .git in your project directory. That's where Git stashes all the info about your project's history, like a behind-the-scenes memory bank. Now that your project is being tracked, you dive into your HTML file, make a few tweaks, and think, okay, I want to save this progress. That's where git add comes in. So what is git add? When you run git add dot, you're telling Git, hey, take note of all these changes and get them ready by sending them into the staging area. The staging area is like a waiting room where your changes hang out before they're officially saved. By using git add, you're saying, I'm ready for these changes to be part of the project. You can also add a specific file by running git add, followed by the file name. Earlier, we used git add dot, which means we want to add all the files in the project folder at once. For example, if you edited a file named index.html, you could run git add index.html to just stage that file. Once everything's prepped in the staging area, it's time to lock it in with a commit. Enter git commit. What does git commit do? Git commit is the command you use to save your changes in Git. When you run it, you're taking a snapshot of everything you've staged, which means those changes are now part of your project's history. Think of it like hitting save on a new version of your project. You also get to add a little message with it by running git commit -m, and then put your message inside the double quote. This message acts like a note to remind you what you changed. So once you've added your changes, running git commit locks them in, and you can always go back to that version later if you need to. In this context, commit is just another word for saving your changes. So let's take a moment to recap each of the basic concepts and commands we've learned so far. First is Git Bash, which is your terminal. In simple terms, this is where you will run your Git commands. You can also use the VS Code terminal if you are working in VS Code. Next is Git init. This command simply initializes Git in your project. After that is Git add. When you make changes to a file, you need to let Git know about those changes. That's when you use Git add. This command prepares your changes and sends them to the staging area. Next is staging area. The staging area is like the counter at the store. It's where you put your items before you officially purchase them. In this area, your changes are all lined up and ready to go. If you have many changes that you've added and want to see them all, you can simply run git status to check what's in your staging area. Finally, you use git commit. When you run this command, you're officially saving your changes and locking them into your project. After you've got the hang of using Git on your local computer, it's time to dive into how you can share your code with the world. Sharing your code lets you collaborate, gain feedback, and boost your career by showcasing your work to the world. Here's where GitHub comes in. GitHub is like the ultimate gallery for your code. It's a platform where you can store your projects online, making it easy for others to see what you've created. Plus, it allows you to track changes, manage versions, and collaborate with others effortlessly. After creating a GitHub account, go to your profile, navigate to Repositories, click New, add a name and description, and then hit Create Repository at the bottom. Simple as that. After that, you'll be taken to the empty repository you just made, where you'll find a bunch of helpful instructions like how to add collaborators and set up GitHub Desktop. We'll dive into that later, but first, let's learn how to use the command line to connect your local Git to GitHub. If you look closely, you'll see we've already done the first part in our local Git, like git init and git commit. The other lines are for your README, which we'll discuss later. To connect your local Git to GitHub, run these 3 lines in your Git Bash. But before we get into that, let's understand what these 3 lines do. First is git branch-m main. This command renames your current branch to main, updating it to the modern convention if it was previously named master or something else. Next up is git remote add origin, and then the location of your repository. This command tells Git where your online repository is located, with origin as a handy nickname, like saving your GitHub repo's address for easy access later. And finally is the git push-u origin main. The push keyword command sends your changes from your local computer to the GitHub repository online. It literally means pushing your code from your local Git to GitHub. Think of it like uploading your project to the cloud so everyone can check it out. After running those 3 lines, refresh your GitHub and voila! You're now sharing and storing your code on GitHub. This means that even if your computer crashes, your code is safe. Now, after learning GitHub, let's now learn how to undo things using Git. First, let's create 3 commits. One for an HTML file, another for a CSS file, and a third for a JavaScript file. Start by creating the HTML file, then run git add dot and git commit with a message of added an HTML file. Next, repeat this process for the CSS and JavaScript files. Now, let's say we deleted the JavaScript file and created a commit afterward, but we made a mistake and want to get it back. So what do we do? The first way is just checking out a previous commit. This basically means you're taking a look at an older version of your code to see what's changed, without actually messing with the project's history. To do this, start by running git log. This command shows you a list of all the commits changes made in your project, so you can see who made each change, when, and what was updated. Each commit has its own ID or commit hash. If you have a lot of commits and the list is overwhelming, try running git log -- one line to keep it short and sweet. If you want to go back and check out what's happening in that commit history, just run git checkout followed by the hash of the commit you want to view. But note that if you run git status, it will inform you that you are now in a detached head state, which means you can only explore the previous commit, but not make any new commits. If you see that the deleted JavaScript file is now there, it means you're looking at that past state, but you can't change anything in it. After you're done checking things out and want to return to the current version of your code, simply run git checkout main. However, we still haven't restored the JavaScript file we wanted. The second way to undo changes in Git is by using revert. Think of it as your oops button that keeps your history tidy. First, check out your past commits with git log and spot the one where you accidentally deleted that JavaScript file. To roll it back, just type git revert, followed by the git hash you wanted to undo, and voila, you'll enter edit mode. Don't panic. You can first tweak the commit message to your liking by hitting I to start editing. Then press escape, followed by semicolon and then W and Q to save and exit like a pro. Now, if you run git log again, you'll see your neat little revert commit in the lineup. So, after getting the hang of revert, what if you just want to hit the cosmic reset button and go back to a simpler time, like before you added all that extra stuff? Enter git reset. If you want to wipe the slate clean and return to the time when you only had the HTML file, just run git reset -- hard, followed by the commit hash you want to go back to. So here's the deal. Git revert keeps your history intact so you can see all your changes and make tweaks without losing progress. But git reset wipes everything back to a specific commit, so use it wisely, like a superhero's powerful tool, only when you really need a fresh start. Now that we know how to undo changes in Git, let's learn about branches. Branches are super helpful in Git because they let you work on different versions of your project at the same time. This way you can try out new features, experiment with ideas, or fix bugs without changing your main project files. A lot of people find branches confusing, so let's make it easier with a simple example and analogy. Imagine you're playing a role-playing game with a character you've been leveling up. You have your main character equipped with all your best gear and stats, but now you're curious about trying out a different skill path or testing new abilities without messing up your main setup. In the game, you create a save slot. This is like a branch in Git. This lets you experiment with different abilities and play styles on a copy of your character. while keeping the original untouched. If you like how the new skills work, you can go back to your main character and apply those changes there. If not, you just delete the save slot and your main character is safe, unchanged. In Git, branches work just like this save slot. You can test things out in a branch, keep your main project safe, and only bring in changes when you're ready. So to understand this more, imagine you're working on a website project and you want to add a new feature like a contact form, but you don't want to mess up your main project files. We'll create a branch for this feature, make some changes, and then merge it back into the main project. Step 1 is to make sure you're on the main branch where the current stable code lives. This branch is often called main or master. You can do this by running git checkout main. Next, to create a new branch, you can use the git branch command followed by the name of your branch. In our case, this is contact form. After creating the branch, you'll need to switch to it to start working on the new feature. You can do this by running git checkout contact form. After running this, the terminal will also say that you are now switched on the branch that you created. To confirm it one last time that you're on the new branch, you can run git status to verify. Now, if you want to speed up your workflow, there's also a shortcut. You can create and switch to a new branch in one step by running git checkout -b contact form. Now you're on the contact form branch and ready to start adding code for the contact form. For example, you might add an HTML file with the contact form layout. Once you've made changes, save them in the branch by running git add dot and git commit -m add contact form layout. When you're satisfied with your work in the branch and ready to merge the changes into the main branch, first go back to the main branch by running git checkout main. Then merge the contact form branch into it. This combines the changes from contact form into main, so the main project now includes the new contact form. If you're done with the contact form branch and don't need it anymore, you can delete it to keep your branches organized by running git branch -d contact form. And there you go. You just created, merged, and deleted a branch. Using branches like this allows you to experiment with new features while keeping your main code safe and stable. To view all the branches you've created, just run git branch. And of course, I know we discussed many concepts today, which is why we created a PDF version of this video. We've included a cheat sheet for Git commands that you might find useful for your development. It's free, but we would greatly appreciate it if you supported our channel. This is just the part 1 of learning how to use Git and GitHub on your own. We will still discuss how to contribute and how to collaborate and such in the next video, so subscribe to stay tuned for that. After learning about Git and GitHub, what would you like to learn more about? Leave us a comment in the comment section, and we will reply to you immediately. Well, that's it for now, Novas. Thank you for watching.